FLIR's been around, like I said earlier, for a long time. We've been around actually in excess of 50 years. We were one of the innovators and the fathers of thermal imaging, and our partnership with Darley is a long-standing partnership. And as that partnership has evolved, thermal imaging cameras have gone from $30,000 plus for a camera down to that sub $2,000 range, and it's all because the power that FLIR has by utilizing all of the different business units that we serve, whether it be the science cameras, whether it be our military, whether it be our law enforcement or our science, and taking all of that technology and bringing it into the fire segment, and all of that technology and the research and development that's gone into it for all of these different segments basically empowers us to bring to you and to your customers and to our customers the best technology at the lowest cost. So in days past, a thermal image was a thermal image. It was a very grainy, fuzzy, black and white or grayscale image. And now we employ two different types of image enhancements on our cameras that allow our first responders and our customers to be able to see in ways that they never had before. We know that a typical thermal imaging camera is not going to be able to read lettering on something, on a sign, or read lettering on a building, like hazard labels. But now, utilizing MSX image enhancement, multispectral image enhancement, we actually have a camera that overlays visual over thermal, and that visual over thermal overlay allows us, as you can see on the right-hand side of the screen, to read labels on electronic equipment, on circuit breakers and fuse boxes, and be able to see, is there a hazard in what we're doing? Where in the past, or with a standard thermal imaging camera that hasn't, or that doesn't have an enhanced image, you would never be able to see that. So here's just an example of a standard thermal image, and this is what you're able to see utilizing multispectral image enhancement. The difference really is night and day. And then in all of our large cameras, we incorporate into it what's called FSX image enhancement, fine spectral image enhancement. And basically, if you look on the left, you see a typical thermal image that's not enhanced, and it's very, very diffuse. It's not real defined or sharp. The borders and what you see isn't really very clear. But when you employ FSX image enhancement, now you're able to see all the stratification of heat and layering. You're able to see things very, very clearly. I mean, up to and including even the water droplets on that firefighter's helmet. So all of these things combine to make thermal imaging cameras today far better than the thermal imagers of yesterday. And like I said, with the cost of the technology being so low, there's really no excuse anymore to say, well, thermal imaging technology is cost prohibitive for for a fire department. We like to design our products based on certain factors. I am sorry, we are really having some issues today with the technology end of this. We like to employ some basic tenets in our products. Number one, we like our products to be very simple for an operator to use. We like our products to be very intuitive. We like the form factor to be such that a firefighter is not having to compromise their safety for by removing layers of protection. We like to make sure that the design is user friendly. It evades whiteout. So we've all heard in the past of thermal imaging cameras that white out. Our cameras don't white out because we have a shutter inside the camera that basically comes down in between the infrared heat source and the microbolometer at given intervals to recalibrate that image to ensure that recalibration prevents the whiteout. We offer a wide dynamic range so that you're measuring heat sources far beyond those found within a typical room and contents fire. And we also employ spot temperature measurement so that utilizing this little green dot in the or box in the center of the screen, you're able to focus that on a given area to get a precise heat measurement for that area. We need to understand that all of these things are great, but unless they're tested, it's just not good enough for our firefighters. So some of the tests that we employ at FLIR to ensure is we'll turn the camera on and we actually throw it into a concrete mixer and tumble it for about 15 minutes. And we have to make sure that at the end of that tumble cycle that camera is fully functional. We do an incineration test to make sure that the camera can withstand high heat and direct flame contact. There's a great case of a camera that was left inside of a fire in Clackamas, Washington, when crews found a victim. Or actually, it was two victims. They removed the victims, but they left the camera inside. They recovered the camera. It was a K2 about 4 hours later, and the camera was still functioning. In fact, we had that camera at FDIC on display this year. And then, of course, we have the vibration test where we'll turn the camera on and and throw it into a vibration chamber, and to make sure that camera and the electronics that make up that camera are all able to withstand vibrations. And then, of course, there's the firefighting testing. We want to make sure that everything that a firefighter could possibly subject that camera to, our camera is going to survive. So it is imperative to us that we make a camera that's going to stand up to everything that you could possibly throw at it and that your customers will ever throw at it. And then we back it up with an industry-leading warranty of 2 years for the battery, 5 years on the camera, bumper to bumper, and 10 years on the core. So with respect to the FLIR infrared camera lineup, all cameras aren't built the same. They're not all there for the same use. So what combination is right for you? What combination is right for your customer? We have cameras that are meant to be mounted onto aerial ladders so that you can view that incident, that scene, from outside and above. You can view the scene using our truck-mounted thermal imaging cameras from the curb or anywhere a piece of fire apparatus is parked. And then, of course, we have our thermal imaging cameras for our decision makers and our thermal imaging cameras for our firefighters. So the KF6 is actually a camera that's meant to be mounted onto an aerial device. It can be mounted onto a platform or onto a straight stick ladder. It takes the signal. We can send the signal wirelessly up to 400 feet down to the turntable. And that image that comes from that camera can be viewed by the turntable operator, an incident commander, or anybody else that sees it. And it's not limited to just the turntable. You can literally mount this camera anywhere, or the viewing part of the camera anywhere on the apparatus. In fact, there's Seagrave apparatus out there right now that have the monitor mounted in the back driver's side compartment. So the incident commander, if they want to see what's going on from above, just has to go to the back of that compartment and open it up and turn it on, and they can see what the camera sees. And then, of course, we have our handheld suite of firefighting thermal imaging cameras. Everything from the K2 with an MSRP of $1,385 that's meant for the individual firefighter, to the K33 and K45, which, in the $3,100 range. The K45 now, our 3-button camera that's able to take pictures and has 5 different image modes for $4,400, all the way up to our K65 NFPA camera that's $6,995 MSRP. And if we look at the resolution of these cameras, this is something that thermal imaging companies were never able to offer in the past, is a wide array of resolutions, everything from lower resolution 160 by 120 with MSX, that multispectral visual camera over thermal camera image enhancement and a 3-inch screen, all the way up to standard resolution 240 by 180 on a 4-inch screen with fine spectral image enhancement to give you the crispest of image, as well as our high resolution cameras 320 by 240 resolution cameras that offer that FSX image enhancement. They have the ability to take pictures as well as record video on a 4-inch screen. So the FLIRs, the KXX series, our K33 through K45 cameras are really the bread and butter of what fire departments buy for making decisions at fire incidents. Our K45 has that 240 by 180 screen resolution. Has an MSRP of $4,450, and it has the ability to take pictures with 5 different image modes. And what are the image modes? TI Basic, which is the standard NFPA user interface, black and white. Fire attack mode, which is basically a mode that works very similar to TI Basic, except for colorization begins at 500 degrees Fahrenheit as opposed to 300 degrees Fahrenheit. And then, of course, our NFPA K65 that has an MSRP of $6,995. The K55 and the 65 both take images and video. They're capable of doing 200 JPEG photos, 200 MPEG videos that are 5 minutes apiece, or any combination of the photos and videos leading to 200 total files. The K33 and 55 are our single button solution for fire departments that say we want very simple. These cameras have one single image mode, TI Basic, which is the standard NFPA user interface. The customer chooses between do they want standard resolution or high resolution, and then the customer decides they want to be able to take pictures and video. The K53 is high resolution with pictures and video. The K33 freezes the image, and as soon as you let go of the trigger on the front of the camera, it goes back to live. The K2 is our 160 by 120 personal thermal imaging camera for individual firefighters for safety and orientation, and it enhances their ability to do their work simultaneously as crews. It has built-in thermal and visual cameras that overlay, that give you an awesome view of what you're looking at. Compact and very easy to use. They're very robust, very reliable. They offer the MSX image enhancement. They have temperature measurement capability. If you take a look at the screen, that square box that's in the center correlates with the bottom right-hand corner temperature measurement, so that you can always keep tabs on what you're looking to measure. And we offer an industry-leading two-year warranty on our battery, 5 years on the camera bumper to bumper, and then 10 years on the camera core across all of our thermal imaging cameras. And all of that for the K2, $1,385. So knowing that, why would you not outfit all firefighters with a K2? Fast search and rescue, speeds up the overhaul process. It's great for nuisance calls. It allows everyone to see, making sure that everyone goes home. So when we do a quick comparison between different thermal imaging cameras on the market, and I just kind of randomly chose a couple out there, we can put our customer into one of our competitors' products, the NXT, when it's outfitted with all of the like features of our K65, it comes out about $12,175 MSRP. But if we really think about it, we can actually put a fire department into 3 K2s and a K65 for $11,150 MSRP to MSRP. We can equip an entire piece of fire apparatus for less than our competition. So when we look at a big city fire department, we'll call it a fire department in Pennsylvania, they have 11 battalion chiefs, 55 engine companies, 27 ladder companies, and 3 rescues, and 4 people on their engines, 5 on their ladders, and 6 on their rescues. We can equip in days gone by, their battalion chiefs, to get them thermal imaging cameras, would be $88,000. To put thermal imaging cameras on their engines, $440,000. To put thermal imaging cameras on their ladders, $216,000. And then to put them on their rescues, it's an additional $24,000. That would have been $768,000, so that they could have 1 camera per rig, giving them 32% of their people having sight. But today, we're able to, because of the decrease in the cost of the technology and to procure that technology, we can give all 11 battalion chiefs a K2 for $15,235, all 55 engines, thermal imaging cameras for everybody for $397,100, all 27 ladders, thermal imaging cameras for everybody for $232,335, and all 3 rescues with thermal imaging cameras for everybody for $29,970. This comes out to a total cost for 100% site of $659,405. So we can give everybody a camera today for less than 32% site in yesterday's world. That's $108,595 savings, and everybody gets to see. So why are we deciding who gets a thermal imaging camera? Why share? All right, well, I thank everybody for their time. I will open it up to questions just momentarily, but I intend on doing another webinar on FLIR products for all of our customers and to our distributors in early October of 2018, so stay tuned. I thank eDarly for sponsoring this. You're a great partner, and I certainly would encourage anybody that is looking for a thermal imaging camera to contact their eDarly rep, and let's see what we can do to help you. As far as FLIR goes, my name is Brent Elliott. I'm the Sales and Distribution Manager for the First Responder Group for the Midwest and the West Coast. There's my contact information. On the East Coast, we have Jason Messerschmidt, who's our National Sales Manager, and he services the Northeast U.S., and that's his contact information. And then we have Kenneth Keel, who handles the Southeast United States, and he's the Sales Manager for that area, and there's his contact information.